Welcome to the 65th video in our series about Unix tools. Traditionally, most software for Unix-like systems was written in C. C was originally created as a high-level cross-platform replacement for assembly language for writing the Unix kernel. Anybody using Unix needs to know how to compile and run simple C programs. This video is not going to attempt to teach you the C language because there are many online sources that will do that. Instead, this video is going to show you how to convert your C source code into something you can actually run on your Unix-like system. And we won't be using Visual Studio Code or anything like that. No IDE. I will use the most commonly available compiler called GCC. Let's start simply and assume that you have all your source code in a single source file called myprog.c and you want to compile, link, and run it. For now, we'll just accept all the default settings from the compiler. And you can see on your screen what we're going to do. So let's exit this. Let's take a look at myprog.c. You can see it's a fairly silly example, but it does have a main, which is necessary, and main calls the procedure talk to me, which is defined here as a void function, but it's really a procedure. It returns nothing, and it prints the message. This is a very simple C program, all in one file. A lot of homework assignments for beginning C programmers will be like this, all in one file. I told you there are two steps. First, you need to compile the source code into an object file. On Windows, those are .obj, but on Unix, those are .o. To do that, with GCC, you say GCC, and then you use the -C switch for compile only, and then you give the name of your source code file, which ours is myprog.c, and then you need to tell him the output where you want it to go. And we want to put it in a file called myprog.o for an object. And if everything's okay, we're accepting all the defaults, it seemed to work. You can see we got a file there. If we run the file command on it, it tells you it's an ELF 64-bit Linux standard base relocatable. It's x86-64, which is really AMD 64, but they didn't want to say Intel 64 and AMD 64, so this is the neutral term for a 64-bit CPU architecture that AMD and Intel make. And it tells you this is not stripped, so it has not removed some extra information that's in there. Now, after you have your object file, if you try to run that, you'll see you can't do it, and the permission doesn't let you do it. That's because it's not designed to be run yet. The compile step will create the object file, but the object file doesn't have the code for printf, for example. We have to link in the standard library. And the way to do that with GCC is you say GCC and then all your object files, we only have one, and then your output, and you say myprog. Now on Windows, you're used to having an exe extension. Unix doesn't do that. They just call it the name of the program. You notice I didn't use this -C switch. That's only for creating these object files. Without the -C switch, GCC tries to create an executable. And we run that, it seems okay. and you'll see my prog is much larger than the object. And that's because it has to have lots of extra code in there to connect up to the printf and use that at runtime. So you notice this has the executable bit set. Can I mark it? I don't know if I can mark just the one letter. Maybe not. But RWX, R minus X, R minus X. And those X's say for a file, and we know it's a file because we start with a minus. It says it's executable. It's something we can run. So if you just type in myprog, it says I can't find it. And that's because on any good system, when you look at your path, you'll see the local directory dot is not on the path. And you should not put it on the path. That's dangerous. When you want to run a file in the current directory, what you do is you put a dot for current directory and then slash and the file name. Like that. And now it worked. It said, wow, this is a C program. And if you can't remember what the code looked like, did it do the right thing? Yes. Here's the message that we wanted to print. And we sent that message as an argument. It came in here. We said printf that argument as a string and give me a new line at the end. That's what that subroutine did. After that, we returned exit success. And you might wonder about that. So after we run myprog, Unix systems have a special variable in the shell called $question. And it's only good for a short time. It holds the return code of the last run executable. And so if we look at it, it destroys it. But at least we can see it. And its return code is 0. 0 means success. Everything's okay. If you got any other value besides 0, your program had some kind of error. And that's why you need to return exit success, which is in the standard lib. And to run printf, you have to use standard IO. Okay. That wasn't so hard. But you wouldn't want to type that 100 times a day. Right? We wouldn't want to have to do that. And before that, we had to do this many, many, many times. Every time you modified your source code and you wanted to test it, you'd have to recompile it and relink it. Your brain is screaming, there must be a better way to do this. And there is. And that'll be a topic of a later video. There's a special program called Make. But for this video, we're almost out of time. So let's make some changes to this program. If you look at this program, you can see it's quite ugly. We don't have any kind of top level comment to tell us who wrote it or what it is. So there are the comments, and then, for this, we've got a comment, and then this, finally, So we've added the comments. We don't have doc strings like Python does, but you still should follow the same basic idea, which is put some comments in front of each subroutine, and you need some comments at the top of the file that include some information about the license, this isn't a wonderful example, but it's good enough. And let's make some changes. Let's print this several times. So it's going to print the message 0, 1, 2, 3, 4. It's going to print it 5 times if we're right. So let's do it again. GCC minus C, the name of my source code, minus O, and the same name as the source code, but change the C to an O. And you see, oh no, I've got an error. And this is what the errors look like. This is a modern version of GCC with this nasty colorized output. But let's fix the error. It tells you, it has a good error message. Much better than when I learned C, where the error messages would give you some number and you had to look it up in a book. This one tells you that variable I that I used as an index is undeclared. And so I need to go in here and declare I. And to declare a variable, you give a type. In this case, I need an integer. Okay. Let's try again. It compiled. The next step is the link, because we only have the one object file. So don't put the minus C this time. Give the object file name and a minus O, and then the same name that you want for your actual program, which for us is myprog. And then to test it, // and the myprog. And you can see it printed it 5 times, just like I said it would. The exit code is 0, which means everything's okay. We've got a good C program. We know how to compile it. So we're done with this video. Now you can compile simple C programs that are all in one file. Thank you for listening.